All right, what we're going to be looking at today is how to take exponential expressions from the word problems and create a function given different pieces. So if you would please, in your journals, right now, I want you guys to write y equals a times b to the power of x. It's been a while since we've done this. Let's just do a quick little review. What does the a represent in these problems? Initial, very good. And what does the b value represent? Either a different type of factor. Either it's a growth or what? Decay factor. Okay, so right now we're looking at this town of Madison. It has a population of 25,000. So if you guys have a population of 25,000, just put A equals 25,000. Has an initial population. Okay, now it says it's increasing by a factor of 1.2. So they actually gave us the factor. What is our factor? 1.12. Does anybody know what percent increase is happening in this particular problem? Like how much is the population increasing each year percentage wise? You can actually interpret that from this. All right, anybody think they know? What you got? What'd you say? You say 112? Okay, 1.12 is 112%, but what are we adding to 100%? We're actually adding 12% to what's already there. So our percent increase per year, it's a 12% increase every single year. Okay, so put slash here. It's a 12% increase. That's how you can interpret the percent increase. Now, what if it was a 12% decrease? We can learn a lot just even from this problem. If it was a 12% decrease, what would our b value be if it was a 12% decrease? Well, what do we start with? We start with what? 100%. And what would we take away from the 100%? 12%. And what would that leave us with? 88%. So if it's a 12% decrease, by the way, you guys could get, just so you guys know, you can get increases and decreases in these problems. So this is why I'm doing this example, okay, in case you get a decrease. So the b value here would be 0.88. Because if you lose 12%, what are you keeping? You still keep 88% of the population, okay? Now, just remember, increase, you're adding to 100%, decrease, you are subtracting from 100%. Okay, so that's basically, it's always what? Adding or subtracting from 100%. So right now, what I'm going to put in as my answers, I'm going to put in 25,000, parentheses 1.12, raised to the power of t. And that's going to be my answer for this. All right, and I'll type it in. Hopefully I will type it in and it will be legible for you guys to be able to see. So we have 25,000, not 2,500, 1.12, and then I got to do the little raise to the power of t because it says p of t. So I'm using t instead of x. All right, we're not going to take as much time on this one. We're just going to look at the amount of deer we're starting with. So right now, if we look at 170 deer, our a value is equal to 170. Once again, it says the deer population is increasing at a rate of 30%. So if we have 100% and it's increasing 30%, now we're at 130%. And what decimal would be 130%? What do you guys say? 1.32. or just 1.3. If you ever want to take a percentage and change it to a decimal, all you have to do is just divide it by 100%, and that will give you the decimal which you seek. That's it. So there are your notes. If you ever want to take a percent and change it to a decimal, just divide it by 100%. Okay? Now, some people will say, we'll just move it to the left two places. Move what? The decimal. 1, 2. And I get you the 1.3. So right here, I'm going to put 170. I'm going to put 1.3. I'm going to raise it to the power of t. And that's going to be my answer. 170, 1.3 raised to the power of t. If they give you a factor of 1.12, then you just use the factor 1.12. But if they give you a percentage that's increasing, then what do? You add it to 100% to get the 1.3. All right? 170, 1.3 raised to the power of t. All right? Now, how to interpret stuff. This is not going to take that long, I don't think. All right? So does everybody see where it says interpreting? I'm not going to make you guys write all these down. So just whatever you're doing, just pay attention for the next 4 problems, and we'll be done with it. Okay? Does everybody see our expression right there? It says 6.7, then it has times 1.45 to the power of t. What's our a value? And what's our b value? What are we starting with? What's our initial value? 6.7. What's our growth factor? 1.4. Okay? All right? So, right now it says, what does the what? 1.45 represent? Well, what does it represent? It represents what's called the growth factor. So, of these choices, what do you guys think it represents? A, B, or C? Is it 1.45 years since 2002? Were there 1.45 billion bases in 2002? Or is it the number of bases is multiplied each year by 1.45? C. Okay. So it's just that's your growth factor. What does the 1.01 represent in that problem? The initial. So we're looking for something that represents the initial amount. Okay? So the expression 1.01, it gives the amount of money. Oh, what is it? Here's the thing. It's 1.01 is in what? Thousands of dollars. So it's got to be C. Okay? That's what the 1.01 represent. That's the initial amount when he opened it. What does the 2 represent right there? What's happening in that problem? That's the growth factor. So what's happening? It's doubling every single year. Is T years? A week. All right? It doubles the number of leaves each multiplied by 2 each week. That's your scale factor. And what does the 5 represent in this one? The initial. Okay? So we're just looking for what? Either the initial or what it's being multiplied by every single time. All right? So 5 represents the initial. The area of 5 has been damaged by the fire by the time it was discovered. So that's what it started with, and then what happens? It keeps growing. The amount that was damaged keeps growing and growing and growing. That's all you guys have to do. All right? So either you're doing what? You're creating your function, or you are interpreting it. And then the quiz is just everything off of that.